Hi. So Casper's been working on some cartoon versions of me and him that we thought we might have some fun use cases for as we're talking about animations and different things you can do on the web. But I asked him to send me over the images, the SVGs, and when I had a look here, it says it's 2 megabytes. That's a 2 megabyte SVG. So I obviously had a look and I downloaded, like peeked in, said, what is going on here? And have a look at this. Right, this is an individual path, and this is like crazy. So what has happened is Figma has this sort of distortion effect you can do on lines that makes it feel more hand-drawn. But what it actually does is just add all these stubs inside the path, and you end up with this 2 megabyte SVG file, which is not going to work on the web, right? Because even the actual JPEG version is going to be smaller, right? Or PNG version. So I asked them to send me the original, and we have that here with some basic lines. So this is just without that sort of Figma displacement or distortion thing they do, right? And let's go and grab this. Let's go and open this one. So this is much more clean. But obviously we like that effect. So we're going to add that in SVG. I'm just going to go and grab this whole SVG item, copy the outer HTML of that, and we'll just paste it directly into Nordcraft. Right, so here we have it inside Nordcraft. Let me just zoom in on the, let's see if I can figure out how to do that. Zoom in on the interface a bit. We'll do one more, because that plays a little bit better on video. Right, so here we have the clean SVG, right? Without any of the sort of distorted line effect. The first thing I'm going to do is I'm going to insert a defs object in the SVG here, right? And then move that up to the top. And defs is short for definitions. It just says you can define a bunch of stuff to be used later, but it doesn't actually render in the SVG, right? This is not an element that's visible. It is just like configuration, in our case, filters. And the next thing I'm doing is going to add a filter, right? Now the filter needs an ID so we can reference it outside. And I'm going to call it hand drawn like this. That's going to be the ID, right? And now the actual, so inside this block, this element, we can put in all the filters, and you can apply multiple filters in sort of one group. And that's actually what we're going to do today. We're first going to apply a turbulence filter, and we're going to use that turbulence to create what's called a displacement map. And I'll explain everything as we go along. First, turbulence. Right, FE turbulence, right? I cannot remember what attributes this takes and how to use it, so I'm going to ask an AI. Right? What attributes does FE turbulence take? And it'll then hopefully explain to us how to actually use this thing. And so again, turbulence creates this noise image that we're going to use to generate essentially random noise, right? Right, so turbulence primarily creates an image using a Perlin turbulence function. I don't know what that is, but it again generates random noise. And we need some attributes. The base frequency, we're going to set that to 0.04 because I've actually tried this before the video, and that's a good value. And then num octave, number of octaves, which is the noise function. Higher value adds more details but are more computationally expensive. Default to 1. We are going to play around with that. I think the one I tried was 3, so we're putting that in as well. And then we don't actually need the seed. That doesn't matter because we don't care about how the randomness of it. It just needs to look nice. But the type doesn't matter. So let's go type, and we're going to say fractal noise. Right, and then in this case, because this is not actually the last filter, like we're going to use this as an input for the next filter, we need to give it the result and name. So we'll do result and then turbulence. Right, so we can actually render this out if you want to see what this thing does. So let's add a rect. Let's give it a width. Can I do it like? Is that fine? No, I need to do. Yeah, actually that was fine. And height 1000 pixels. Yeah, that was okay. So you can normally do that. Some style properties are shared between SVG and CSS, but not all of them. So in this case, we need one more with the filter, and I don't think we could do this with CSS. I actually haven't tried, but I don't think we will use the CSS filter. I think we need to use this one for that. So we call this hand drawn. Right, and when we add the filter to it, we can see this noise that we've generated, right? Which is like a red, blue, and green noise image we've created. And we can see as we change these things, like, let's happen if we just do one number. Okay, 2, 3, like we can see as this, we change it. 40, 30, that doesn't seem to do anything, 10. I haven't quite figured out exactly how the detail works here. I haven't played around with enough, but 3 seems to be a good number for number of octaves. So that's what we're going with. It doesn't seem to change anything, adding more. And you can also see here as we change the base frequency, like let's start with 0.1, we get a quite rough image with large like chunks. And we can see we get, as the frequency changes, we get a more fine image, right? So 4, right? It gets finer and finer. And 0.3 was the one that kind of worked with what I was doing. But we can play around with this afterwards. Right? So now you kind of get the idea of what this image does, like this, as we apply this turbulence, right? This image we've created, this turbulence image, we don't actually need it directly. We only need it to feed it in to our second filter, which is called a displacement map. So let's go and add that. And again, what about displacement map? I can't remember the attribute, so we're asking the AI again. Okay, it's just gonna scan real quick and says, oh, you told me about all these things, because we did use this thing in our liquid glass videos. So I found a lot of reference there. You can go and check that. We'll link it in the description as well. And here it basically says, well, you have these 2 in attributes, in 1 and in 2. So in 1 is the image to be displaced, e.g. source graphic. And source graphic here is a special magic word that means the image we apply the filter to. And that's what we want in 1. That's pretty much always what you want in 1, like at least most of the cases, right? So we're adding in, what we see immediately is that it now stopped working this one, because now that we added this new displacement map and this, and it took in the source graphic, this is actually now applied, and the rect doesn't really work anymore, right? So we can cut that out. It's just because now the new image it generates isn't only based on the turbulence, it also runs through this displacement map. And as a result, the output of that is what being applied to the rect. In this case, you can't see that. So the second thing we need to add here is in2, because people making HTML spec are really good at naming things, just like you and I. So in2 is the displacement map image, which is in this case our turbulence. So we are going to add in2 turbulence. Then there is a scale. The scale factor, higher values create stronger distortion. Good. Again, I did play around with this, and I found out that 5 was a good start. We can adjust it later on. Then we have X channel selector and Y channel selector. So if you remember how the the filter before, right? So X channel basically means it'll look at a color in the displacement map image, and based on the color value of one of those channels, the red, blue, or the green, it's going to displace that in the X-axis. And the Y channel selector is going to pick pick which of these channel displaces in the Y. And the channels, possible channels are red, green, blue, or alpha, because those are the type of values in an image, right? And we can actually go back here a bit. Let's go there. So now you can see, like, for each of these, it basically looks and saying how much red is in the pixel right there, and then that's how much it's going to displace it on this axis. How much green, let's say, that's going to displace on the other axis, and it creates this sort of distortion effect. And it's really hard to explain, but it is much easier to see, right? So we'll just redo all these things, right? So X channel selector, we are going to say red, or R, as it asked us to, and Y channel selector is going to be G. And we do not need any of the other things in this case. I think that's all we need. Yes. So now we've created, now we just need to apply this filter to all the elements inside this G. And G is like a graphic group in SVG, or group in SVG, right? And we can apply a filter to that by saying filter, URL, and then hash for the ID, and we call it hand drawn. And that was wrong. And if we noticed, it's really hard to see. I'll try and zoom in quite a lot. But you notice now we get this sort of squiggly line. Like, it used to be completely clean, right? If I cut this out, we get a very clean line. And when I put this in, we get this quite squiggly line that looks way more hand-drawn. Let's shut that down, right? And see, we can sort of play around with this now and do different things. So the biggest, I've noticed that actually, let's go back in. I noticed that changing turbulence doesn't have the biggest effect generally. Like, it does change how things, like how much it sort of wobbles, if you will. Like, the frequency here, right? How often it wobbles. We want something quite low, because I think something like this is just like, that feels almost too rugged for a pencil, right? So maybe 0.5, something like that's pretty okay. That still gives some edge and some grit to it. Maybe even down to 0.3. Here. Yeah. In between, good compromise, 0.4, right? The number of octaves didn't seem to do very much. Like, if you get down to 1, it doesn't do very much. But 2, 3, it's a very minor change, really. It doesn't seem to do a ton. And since it's more computationally intensive with higher, I don't think we're going to go past 3. The fractional noise, we can try and remove that, and then we get like a normal turbulence. But the fractional noise actually looks more like it's a hand. It looks a bit more smooth and more hand-drawn. It's kind of the same effect we actually used on the glass one. So I think that type of turbulence filter just works better. For displacement map, we can play around with scale. That's kind of the intensity of this effect, right? And if you take it too far, it stops looking like a hand drawn. Like, once we get in here, it doesn't look like you've drawn it anymore. So you gotta like stick within what works here. And I think about 5. But we could actually make, we could bind this to a variable, right? And we'll say scale, and we'll start at 5. And then let's go and add an input here. Here we are. See, there should be an input element, and we'll make it of type range. We'll bind it to our scale and give it a minimum value of 0, a max value of 20, because that is way weird. And then inside our our displacement map filter, we'll just use that variable instead, right? So now we get this sort of fun little tool where we can sort of adjust how much do we want, and we can kind of, it's kind of hard to actually see because it keeps staying at, okay, fair enough. But we can sort of see, hopefully you can see, we get to sort of slide to how much of this hand-drawn field do we want, right? And again, my sort of hunch was that, again, around those 5 actually gives us the best look. We can maybe dial it up one more, two. Yeah, five, maybe 8. Maybe we'll give it 8. That was 7. Cool. So the benefit here is that if I go here and inspect, right, like I get all of this for 11 kilobytes, right? That whole website, including the whole thing, right, is just 11 kilobytes to load compared to what we had before, which was like 2 megabytes. So by using the SFE turbulence filter instead and using the displacement map, we can just create the same effect without having to pay that massive load cost up front, right? So I'll link everything in the description, including a link to this project so you can check it out. I'll put a link to the liquid glass effect we used also with SVG filters, the same turbulent displacement map filters. Yeah, and go try that out. Check out Nordcraft. Remember to like and subscribe if you like this video, because that lets us know we should do more of them. So yeah, have fun with this. I've really enjoyed playing with it. I hope you will too.